Okay, so we're continuing with chapter 4. We are going to be looking at things beyond the median and interquartile range, which is what we did in class today. So let's take a look at mean and standard deviation as ways to look at the data as well. So mean, as you know, is the average. Easy enough. They have this fancy formula in front of us here, but we all know it's just going to be adding up the total number of items that are in the data set and dividing that by the number of items that are there. So fancy formula, fine, but the mean is also the average. Okay, we use mean when we have symmetric data. We will use median when the data is skewed.
Mr. Cena, if you are in the building, please call the main office. Mr. Cena, please call the main office.
Okay, easy enough. The mean feels like the center because it is the point where the histogram balances. So in the case of our problem with the median, we were saying that it was around 7.0. It looks as though based on the data with the earthquakes, it is around 7.0 as well, but it looks like it's a little bit further over, maybe more like within the 7.0 bin. It is the point where it balances. So the issue is when to use mean and when to use median. And the median considers only the order of the values. So the median is the middle number. No matter how many numbers are in the list, it's the middle number. It's resistant to extraordinarily large or small data. So oftentimes you're going to hear the median household income. Why? Because median household income, we can all agree that the lowest someone can be making in a household, unfortunately, is zero. But the most someone can be making is multi-millions of dollars, skewing the data. So when we talk about median household income, it tells us what the middle 50% of a location, of a town, of a city, or of a state are making. Certainly, we can all agree that the median household income in certain parts of New York, for instance, Westchester, though not for everybody, but the median is probably higher than if we went to some place like Utica or Ithaca, where it's going to be there's less going on up there. There's more industry that has died out over the years. They're not closer to the city where people on Wall Street traditionally have been making more money. So median household income, they also talk about median price value, house value, median house value. Same idea. You can have very small houses. In this area, would probably be a couple $100,000, but you can have mansions on the same street even. And they usually talk about the median house value for that. To choose between the mean and the median, start by looking at the data. If the histogram is symmetric and there are no outliers, use the mean. So therefore, if it's skewed, or with outliers, we're going to use the median. Okay. All right, so I have a question. Let me make sure I can get you to see the entire question, and then we will reconvene. Please answer this question. All right, so to go back to what we were doing yesterday, we had just talked about the interquartile range. We talked about it being the middle 50%. It's going to be between the 25th and the 75th percentiles. That's going to be our IQR, and it's the middle 50%. Again, just like median, it is not going to be swayed by extreme numbers. The example I talked about today was SAT interquartile range. When you're looking at schools, they told you that maybe the SAT to get into the school, I don't know. I think BC was like something, I don't know. I want to say it was like 1440. You guys might remember. I remember just sitting there like, that's so high, because my daughter hadn't and still hasn't taken the SAT. So I'm looking at these numbers like, yow, this is like the middle 50%. So that means that only 25% of people have less than that. Well, don't forget, those could be athletes, like someone said, maybe alumni, there for special situations. But for the most part, the middle 50% would be here. Why is this important? Let's just say that they have someone on scholarship to play hockey, for instance, if we're talking about BU, and they're there and they have a SAT score of 1,000, right? Combined, that would not really sway the middle IQR that much at all. It won't at all, because it's so low. That would be one of the rare people at the school, the lower 25th percentile, that would actually be having an SAT score that low. No offense to hockey players. I'm not trying to pick a battle. I'm just trying to think of something that I know BU is known for, which hockey I know is one of them. Okay. We're going to be looking at the 5-number summary next chapter, so I'm going to gloss over this, but certainly when we have a maximum and minimum, we can find the range, and when we have a Q1 and Q3, we can find the IQR. The last thing we're going to talk about is standard deviation for spread. So we have range and we have IQR. And certainly range is going to be affected by sways in large and small movements, large numbers and small numbers in a data set. Standard deviation is more powerful than IQR. It takes into account how far each data value is away from the mean, how far each data value is from the mean. So standard deviation and mean are used together. That's the mean, and there's your standard deviation. Deviation is the distance that a data value is from the mean. Okay, so adding all the deviations together would total 0. What we actually do is we square each deviation and find an average of sorts, though it's not quite an average, and I'll show you the formula right now. Oh, I have a problem. Sorry for right now. Answer this question, and then we'll move on. Okay, so the formula for standard deviation is as follows. We actually first are going to start out with the variance. And what this is saying is this is the summation meaning adding them together. So we're adding together the difference between the actual number, the number that we're seeing, the individual data sets, minus the average squared. And then we add the next one, and then we add the next one, and we add the next one. So each data set we have, we take the data number, individual numbers, minus the average, square it, and then keep going. And it's divided by n minus 1, so it's almost averaged. You don't need to ever use this formula. You need to understand it, but you will not, in statistics in our class, in AP Stats, ever have to manually find the standard deviation. Now, just so we're clear, what we're seeing right this second is the variance. It's noted by S squared. It's the standard deviation squared. We're going to use it later, but we're showing it to you all because once if it's S squared and we take the square root of it, we're left with the square root of the summation of each data point minus the average squared over n minus 1. Okay. Since statistics is about variation, spread is an important fundamental concept. It's very important. We're going to be talking about spread. So we have range, we have IQR, and now we have standard deviation. Okay. Measures of spread help us talk about what we don't know. When the data values are tightly clustered around the center of the distribution, the IQR and the standard deviation will be small. However, when the data values are scattered far from the center, the IQR and the standard deviation will be large. Similarly, if we add a big number to one side or the other, so if, for instance, someone moves into our neighborhood that is making multi-millions of dollars, the IQR will not change, but the standard deviation will, because now we are adding to it an additional number to our summation that is far from the average. Here's our last question. Please answer it.